Composition: quartz and feldspar are as important in mudrock as they are in sandstone. Fine-grained micas and clay minerals replace the rock fragment component. Boggs, 1992, defines a typical shale contains 30% quartz, 10% feldspar, and 50% clay minerals, or fine micas. 10% is cement, mainly carbonate or iron oxide. Courses in mineralogy rarely discuss the clay minerals in much detail, so we will review the important ones found in most modern and ancient muds. Because clays are very complex chemically and mineralogically, however, the simplified discussion below ignores much of the variability and most of the less common clay types found in the real world. Clays are phyllosilicates, minerals that consist of tightly bonded sheets of silicate tetrahedra, T-sheets, internally linked together with shared corner oxygen anions. Oxygen. Silicon. Tetrahedral. Silicon oxygen tetrahedral layers sheet. Octahedral. Al, Ca, Mg, Fe. Aluminum hydroxyl octahedral layers sheet. O. 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 Attached to these tetrahedral sheets and mutually sharing certain components with them are octahedral sheets, O sheets. They are composed of hydroxyl, O, anions arranged around cations such as calcium, aluminum, and magnesium. As a separate mineral made of aluminum hydroxide, this combination is known as gibbsite, so the octahedral layer is sometimes called the gibbsite-like sheet. From these two basic building blocks, plus additional cations and anions, a great variety of clay minerals can be constructed. Most are composed of sandwiches of tetrahedral or octahedral sheets, which repeat over and over again. Various cations and anions are found between the sandwiches, resulting in much chemical variability.